All right. So let's say that I have this circuit, and my question is, in 3 minutes, how much energy is supplied or absorbed by the voltage source?
This is looking for joules.
This is looking for joules. So when you're asking for energy, you're going to be looking for joules. I suppose you could give it in kilowatt hours, but if it doesn't say, but I would give it in joules. So to find the power for a voltage source, we really can only use P equals IV. You can't use any of the ones that have resistance because there is no resistor in the voltage source. I could find the power of everything else and then know that power absorbed has to equal power supplied, and I could find it that way. But I think the easiest way is probably going to be to find the current, and then once I find the current, to then use P equals IV. So we can find the current in any number of ways. I know the way I would do it, and it's not the way y'all would do it, because I would do a source transformation, because that's what I do with a current source and a resistor. But I'm not going to do, I am going to make sure that y'all know how to do it, but not just right now for the test. So how do y'all want to find the current?
Nodal?
Sure, let's do nodal. I don't have a right answer. I think nodal is good. So I am going to put ground right there. The reason I'm going to put ground right there is then I know that this is 2 volts. If I put ground right here, would this still be 2 volts? No, because of that resistor in the way. So it's only 2 volts because the other side of it is ground. Okay, so that's 2 volts right there. And so I've got a node here, and I have a node here. So starting with V1, I have, on this direction, I have a current. It's a current coming in, so that makes it negative, so negative 0.5. Going down, I have plus V1 minus V2 over 3. Going to the right, I have V1 minus 2 over 10, and that has to equal 0. Now, on my V2 node, I have the 0.5 is leaving it, so that's positive, plus V2 minus V1 over 3, plus V2 minus 0 over 1 equals 0. So I now have, for this top equation, let's see, I'm going to rearrange this, and I'll multiply the top equation through by 30. So that gives me, I'll take 30 times negative 0.5 is 15. When I take it to the other side, I get 15. And then 30 times this first expression, the 3 will cancel, I'll have 10. So I'll have 10 V1 minus 10 V2. When I multiply by the second expression, the 10 will cancel with the 30 and I'll get 3. So plus 3V1 minus 6. And then the bottom equation, I'll multiply through by 3, and I'll get 1.5 plus V2 minus V1 plus 3v2 equals 0. So then this becomes 13v1 minus 10v2 equals 21, and negative v1 plus 4v2 equals negative 1.5. And then if I multiply the bottom equation by 13, and I get negative 13v1 plus 52v2 equals negative 19.5. It is. Okay, and then I have my top equation was 13v1 plus 10v2 equals 21. Add these together and I get 62v2 equals negative positive, I should be able to do that without making a mistake, positive 1.5, and then I get the answer that I would get from having made up this question, a very ridiculous voltage of 1.5 divided by 62 is 0.024 volts. All right, so if V2 is 0.024 volts, then what does that tell us? Where can we go from there?
So we need current bottom.
We can get the current on the bottom. We know
That's voltage.
that's voltage. Yeah, but I know the voltage here is 0.024 volts, which is higher than the voltage here, which is 0. So I know I've got current going this direction here that I can call I, and I know the current from here to here has to be 0.024 minus 0 over 1, which is 0.024 amps. So my current is 0.024 amps.
And that's on that line after the 1 ohm resistor. So going through the voltage source, we have 0.24 amps.
Exactly, because the 1 ohm, the 2 volt, and the 10 ohm are all in series, so they all have to have the same current. So things in series have the same current. So now I know the current for the voltage source. So I know the power for the voltage source is 2 times, now let's look, it's going into the negative terminal. So that's going to be negative 2, 0.024, and that's negative 0.048. Watts. So is it supplying or absorbing? It is supplying because it's negative. Okay, so it's supplying, and we're supposed to find out how much energy. So energy, which your textbook uses W for energy, which is work, but I don't like it. Yeah, I agree. It yes, exactly. And anyway, energy, power is energy over time. So energy is power times time, or 0.048 watts. Now, what is watts made of? Like, if I need to get joules, what is a watt?
You gotta put it in the seconds.
I got to put it in seconds because a watt is a joule per second. So I said 3 minutes. So that's 180 seconds.
Then do you also need to keep the negative?
No, I don't. The negative just tells me it's supplied, and once I know that and the answer is asking how much energy, I put it as a positive number and say supplied.
So it always would be supplied at that point, but you know it's negative.
Right. So I would say a tiny little amount of 8.7 joules supplied.
Is it wrong to leave the negative sign?
It is. You can have a negative sign without, so you could say, you don't want to say negative 8.7 joules. That you can't have the negative sign here. But to have the power, you could say the power is negative 0.048 watts. But you cannot say the power is negative 0.048 watts supplied. So you either keep the negative or you say supplied, but I say don't keep the negative. So I've
It's like making a double negative.
right, and so and it's just not really done. So
Points off of that quiz.
what's that?
I'm gonna get points off of the quiz.
I can't guarantee that anyone else would take points off for it. I would, but I also would have stressed it in class. But it's not.
Did, I just don't remember.
Yeah.
This is I've got a question more so about how we're calculating the power of the voltage source. Because I understand that, I understand that the formula is voltage times current, and we have the voltage current of the voltage source. But I would think, but since there's two current sources, some of that current.
What do you mean two current sources?
I mean, there's the current source and the voltage source. The voltage source is creating current. Well, more so in that you have two different EMF devices. Is that the proper term?
So I have two different sources of power. Yes.
Yes. So what I'm wondering is that since some of the current that is flowing through the voltage source is going to be created by the 0.5 amps, that current source, wouldn't that sort of mess with the calculation of the power created from the voltage source?
No, it really doesn't matter. So, like, for instance, if I am holding a certain amount of weight, and you say, okay, well, what's the force on your hand? Do you care that it's made up of like two different things, or you just say, well, the force is what it is, and it might be coming from different things, but that measurement is just the measurement, and the measurement for the voltage source, if you take the voltage and the current, that is the power for the voltage source, and it doesn't really matter if how it arose. It's just that is it, and so it does not matter. That's when I'm looking for the power for the voltage source. All I need is the voltage and the current, and that answers it. And it doesn't matter where it came from.
All right.
Okay, so because it very well could have turned out that the voltage source was absorbing power, in which case it would have definitely been coming from the current source. But it doesn't matter. We're measuring the voltage source, and the voltage source is going to tell us the power that it is either creating or absorbing, that the power that it's associated with. So, does that answer your question?
Kind of.
Okay, now, if I needed to find the total power supplied in this circuit, I would need to find out the power supplied by the current source and then add the two of them together, if that was the question.
Oh, it was more so just general confusion about how the math would work. Because I was like, if the current source was a million amps, you'd figure that the current going into the voltage source would be more. Therefore, the calculation would say that the voltage source is producing more power even though the voltage.
No, it would say the voltage source was absorbing power. Because if the current source was producing that much, the voltage source would be absorbing it. And then we would capture that. Because when we'd measure it, we'd see, wow, that's a whole lot of current going through that tiny little voltage there. That's a lot of power being absorbed.
Okay, that makes more sense.
Yeah. Okay, that helped clarify it?
It
Yeah.
does, yeah.
Okay. All right, let me think what else. Let's say I had my power as a function of time is 3t squared plus 2t, and my voltage as a function of time is 3t plus 2. How much charge accumulates from time t equals 0 to t equals 5 seconds. This power is in watts, the voltage is in volts. Anybody have any clue as to how we're going to go about doing this?
Integrals.
We're going to get to an integral, yep. So integrals are going to be there. When I see how much charge, what's the symbol for charge? Q. It is. And I, what is I?
Oh yeah,
Current. And how are they related?
it's current.
Current, the derivative, your currency.
A current is charge over time. So if you have the charge at any given, no, if you have the current at any given time, the derivative would be charge.
Other way around. So the current is dq dt. The current is the derivative of charge. So the charge is the integral, right. So, okay. But I don't have the current. I gave you power and voltage.
Real quick, so it's t equals 0 to t equals, what is that?
That's a 5. My 5s and s's look identical.
That's 5s question mark.
Yep. Okay. We have another relationship that we haven't used yet. We know P equals IV. So power, so 3t squared plus 2t equals my function of current times V, which is 3t plus 2. So what is I?
Well, it would just be T, but that seems like it's wrong.
No, that's right. I made it up to be that way. Yeah, it should seem wrong. I of t equals t. What's wrong with that? Why is that like a ridiculous function?
So it's just T.
Yeah, I of t is t amps. What does that mean is happening over time?
Current shaker.
And it's just growing and growing and growing and growing and growing. So it's not a very good, I mean, you can't have this lasting for very long because, you know, if you are lasting for 1 minute, then you have a current of 60 amps, which is a huge current.
And
Yeah.
it will,
Right. But, so we're having, so this is just to get used to what we would need to do. So now to find the charge that's accumulated, we will do the integral from 0 to 5 of t dt. So 1/2 t squared from 0 to 5 or 25 over 2, or 12.5 coulombs, which is actually a huge chunk of charge. A coulomb is a very large amount of charge.
Yeah, because in physics we're dealing with nanocoulombs.
Right,
Which
right,
would mean charge is very large in that way.
right. So this is just a problem I just made up with numbers that would be easy so that we could practice that. Okay, let's do one more.
So you kind of just, the 3t squared plus t is kind of extraneous.
No, I used that to find that I of t was t.
Oh, okay. Oh, I see.
Yeah. Yeah, this is weird. I've never seen a problem like this before. I just made it up. But what I have seen is that they give you current as e to the negative 2t and voltage as 3t, and then you find power is e to the negative
A lot of the
2t
problems
times
for
3t.
For this sort of thing, has always seemed like graphs.
Okay, let's do one of those
Yeah,
then.
what we do-
Let's do some
are
graphs.
somewhere on the back end.
All right, let's do those.
And it's essentially you do a bunch of integrals, but beyond that.
It's always just getting them started. Like once you get the end of the roll line,
That's my.
it's just getting them written down.
Yeah, I see what you wrote. I kind of popped out for some reason.
What's that? You need
May I
to.
ask you- just glance at the screen real quick of the.
Yeah. Hold on just a second. Let me get to where I'm trying to get to, and then I'll go back to what you want to look at.
Ooh, the Tempest.
Yeah, I got all kinds of stuff in here. Is this the right circuits textbook? Yes. Okay. There we go. Is that what you needed?
Yeah, I just want to glance at that real quick. Thanks.
Okay. Actually, I did not. I just got to general last place. I don't know where they are. There are some good graphs. Okay, here we go. Okay, there we go. All right, let's take a look at, we'll just look at all of these. So the plot in figure 1.22 displays the cumulative amount of charge Q of t that is, let me just grab these so I can write on them. All right, so the top one. The plot displays the cumulative amount of charge that has entered a certain device. what is the current at these various different times? Okay, so I know that current is dq dt. And I know that derivative means slope. And when I have straight lines, I say, yay, I know how to get slopes of straight lines. Slopes are y2 minus y1 over x2 minus x1, or rise over run. So at time t equals 1, I'm in this first part. And so I want the slope of that first part from 0 to 2 seconds. I go up 4 coulombs over 2 seconds. And so I get 2 amps. At 3 seconds, I've got a horizontal line that has slope 0, so that's 0 amps. At 6 seconds, I can see that from 4 to 6 seconds, I go down minus 4 coulombs. I go over 2 seconds, so that gives me minus 2 amps. So to get the current from a charge of, from a graph of charge, you just find the slope. So, problem 123.
The one above your graph,
Yep.
that one.
All right. So this one,
Yeah, 1.21.
so we're given the current, and it is a piecewise defined function. So I know that, like a lot of our functions are going to be in electrical engineering, it starts at 0. So before 0, it's 0. Between 0 and 5, it equals 6t. That is a line, 1, 2, 3, 4, 5. And so it's a straight line, so all I need to do is find 2 points to be able to graph it. So when t is 0, I is 0, so I've got that point. And when t is 5, I is 30, so I'll just go by tens, 10, 20, 30, and then I'll label this I in amps and t in seconds. So at 5 seconds, I have 30 amps, and that's a straight line. And then for t greater than 5, I have an exponential function, and it has a negative exponent, and that tells me it's decaying down to 0. Because if you go all the way to infinity, e to the negative infinity is 0. This t, the minus 5, tells me, well, this is an exponential graph that's shifted to the right 5. I know what exponential decay looks like. It looks like that. And if I plug 5 in, I get an exponent of 0. E to the 0 is 1. And so this is 30 times 1. So when it's 5, it is at 30. And then it's just decaying down like that. And you wouldn't be expected to have it like more detailed than that. So that is the current. But then it's asking for the charge versus t. So what did we say charge was relative to current?
Or the integral.
Integral.
Sorry.
Yep.
I was thinking the current is different.
So q of t equals the integral of I of t but you do have to worry about what the charge was at the time that you started, because when you integrate, there is that constant of integration. So this would be from 0 to t. Okay, so,
So it's up.
so there was no charge before time t equals 0. So I know that at 0 that there was no buildup of charge. So then to get, so it's really this plus however much you had at 0. So this is the integral from 0 to t of 6t dt, which is 3t squared plus a constant which is 0. So it's 3t squared. So we've got from 0 to 5, it's 3t squared. If I plug 5 in, I get 75. So this will be Q in coulombs. So 20, 40, 60, 80. So I'll make that 75. And 3t squared is a parabola. And then to integrate 30e to the negative 0.6 t minus 5 dt, I'm going to get 30e to the negative 0.6 t to the negative 5 over negative 0.06 plus q of 5. Gets me negative 500. Plus 75. So that would look like, I don't know. Doesn't quite seem possible to me. Let me see what. So it would look like something weird. So, but that can't be right. So, yeah. So I don't know. Oh, that's not important. I don't think you'll have one like that.
Okay.
Yeah. All right. So going back to the others. We talked about getting the current. Let's say we have a graph of the current and we want to get the charge. That is the QDT. Where there's not one there. I'm sure there is one. Let me find one in your book.
Yeah, this is what our homework looked like. I did it at the very beginning, so I'm happy we're going over it.
I went and looked at it while I was studying over the weekend and trying to make sense of it.
So I'm going to do one thing with it that's not on here. So the first thing I'm going to do is say that if the first question I'm going to ask is how much charge accumulates from t equals 0 to t equals 2 seconds. So for that, you would get the integral of the current graph. So if current equals dq dt, then charge equals the integral of I dt. So to get the charge, you'd find the integral, which is the area under the curve. And these are rectangles. So the charge is going to be 10 amps times 1 second plus 5 amps times 1 second, which would be 150 plus 5, or 155 coulombs. All right, now the question is asking to sketch the corresponding power and calculate the energy absorbed by it. So what I see here is that I know that power equals current times voltage. So I need to multiply together this part and this part and this part and this part. So I can write these out. I can say I equals 10 for t between 0 and 1, and I equals 5 for t between 1 and 2. And I can write that V equals, this is a straight line, goes through the origin, and it has slope 5. It goes up 5 over 1. So it is 5t for 0 less than t and less than 1. You can look at this one and see that it has the same slantiness, but in the opposite direction. So its slope is going to be negative 5. Or you could just say it goes down 5 and over 1, negative 5t, plus whatever its y-intercept is. What's its y-intercept going to be?
5 volt.
Uh,
Oh, and wire or something, sorry.
Yeah. So if going from 1 to 2, I went down 5 volts, and it's a straight line, if I were to extend it over this way, how far would I have gone down between 0 and 1?
10?
Are you giving the answer? Is that it's 10 up here?
10 up there?
It would be 10 up there. Yeah. And just, you can just kind of eyeball it, or you could do more to figure it out, but I mean, it's
Kind of just infer from
right. Now, you don't actually need these in order to answer this, but this will just kind of prove the point that power is now current times voltage. So power is 50t from t between 0 and 1. And between 1 and 2, it is negative 25t plus 50. So those are also lines. And so from 0 to 1, it's 50t. So it starts at 0. To graph a line, you just need 2 points. So at 0, it's 0, and at 1, it's 50. And this is also a line, and I also just need 2 points. And at t is 1 to 2, it's really discontinuous. So if I plug in 1, I get 25. And if I plug in 2, I get 0. And engineers like to draw these horizontal lines, vertical lines, which I don't like, but they do. And the other way to have done this was to look at our graphs and realize that this is a straight line and this is a constant. It's just a number, it's just the number 10. So all this is doing is multiplying our line by 10. It's stretching it by 10. So multiply the y values of each of the endpoints by 10. So 0, and the y value here was 5. Multiply that by 10, you get 50. That gets you that one. This one is being multiplied by 5. So you multiply each of the y values by 5, and you get the other part.
And by each of the y values, do you mean the y intercept?
No, I mean the actual point right here. So this is the point 1, 5. So if I multiply the equation by it, I'm really multiplying the y value. So I'd multiply, so for this first one, and this is 0, 0. So if I multiply that by 10, I get 0, 0. If I multiply this by 10, I get 150. And then when I'm on this side, when I multiply this point by 5, I get 125. And here I get 2, 0. I just multiply the y value by the constant. What if we had... That's supposed to be the point 2, 1, and that's supposed to be the point 4, 2. And this is supposed to be 1, 1, 2, 2, and 3, 3. So what would the power look like?
Would it be? You'd have to take this, well,
So all we really have to do, so let's do a little thinking first, and those are, I meant for those to be straight lines. So they're linear, so t into t. So what's a t times a t give you?
T squared,
And what does that look like?
a slope, like
A parabola.
yeah,
Parabola. But all I really have to do is multiply the y values together of the points. So at 1, my y value here is 1/2. So my current has 1, 1, 1, 2, 2, 2, 3, 3, 4, 4. My voltage has 1.5, 2, 1, 3, 1.5, and 4, 2. So to get my power, I multiply together the y coordinates. So 1 times 0.5 is 0.5. So at 1, I have 0.5. 2 times 1 is 2. So at 2, I have 2. 3 times 1.5 is 4.5. And 4 times 2 is 8. So at 4, I have 8. And I know it's supposed to be parabola shaped, so I try to draw it kind of parabolically.
That makes sense.
So does that help?
For sure.
All right. Well, I think I have to go unless there are any last questions.
I think we've hooked you up enough.
30 minutes in.
Yes.
Besides, you've been rated as SI Leader of the Month. So.
Is that already like listed
Well, I
somewhere?
just saw someone sent in the group chat for
Oh, yeah, it's,
at the PFT.
Yeah.
PFT.
oh, and I never gave them, like, I was supposed to give them information and like a photo. Did they find a photo?
No, it
Okay.
just says SI Leader of the Month.
Okay, bye, everybody.
Thank you.
Thank you. Bye.
Bye.
Time to take the PFT and finish making this.
Oh, what I was going to say also about Verilog, and I forgot to mention it. I meant to. I have all the stuff you need in my office, and you can always make an appointment to come see me. It's like I'm available. I am and I am not available. It's hard to find a time, but I will find one. And so just call, get to me early, and it's free, and you can see me, and we just have to find a time to make it work.
Definitely have to keep that in mind.
Actually, I know something that would help a lot, actually. I know, at least for me.
All right.
Sample files, like, I understand that that's
Oh,
gonna
sure.
be, like, a lot of doing, like,
Not really. I already have so many done. Like over the years, like I've done so many, just like with worksheets for stuff, it's like I've done so many for all the labs that y'all do, I do them too, and so I've got them, so I've got samples.
yeah, I think that would be the best resource possible.
That's an
because-
excellent idea.
Because like normally, like I'm the guy that I always basically copy and paste code and then rework it. I mean, and like I know a lot of people that would help because